to go like down farther from parallelograms. We talked about how quadrilaterals are broken into three kinds of shapes: parallelograms, trapezoids, and then regular. And then parallelograms then are broken into two kinds themselves. Parallelograms can be rectangles or parallelograms can be rhombuses. And we're going to learn the characteristics of each of those, and also squares. And based on their characteristics, we're going to solve equations and prove that they're rectangles or parallelograms, just like we did, or rectangles or rhombuses, just like we did with parallelograms. So let's start with rectangles. Okay? Rectangles are parallelograms first and foremost. So all the stuff we know about parallelograms also is true about rectangles. So the opposite angles are equal. Consecutive angles are supplementary. Opposite sides are equal. Opposite sides are parallel. Diagonals bisect each other. All that's true about rectangles. Plus, for right angles and diagonals are congruent. So those two are going to be our new ones just for rectangles. They're specific to rectangles. Diagonals are congruent, and it has four right angles. All right, so if you look at this one, can I solve that? Can I figure out what n is? Four right angles, all the parallelogram ones, plus four right angles and diagonals are congruent. Yes, that's for rectangles. And that's the symbol for rectangle. It's an actual rectangle. All right, so is there one of these characteristics that would help us solve for n? Yeah, four right angles. So we know this is equal to what? 90. So I do 5n minus 15 equals 90. Okay? Add 15 to both sides. That gives me 5n is 105. Divide by 5, so n is 21. Okay? How about this one? Is there a characteristic of rectangles that would help me solve for a here? Why are they equal to each other? You're right. Why are they equal? Diagonals are congruent. So this whole side is equal to this whole side. Why would this piece be equal to that piece? Right. Does that make sense? Because if these two are equal and we split them both in half, wouldn't all the halves also be equal? Right? Like half of 2 is 1, and half of 2 somewhere else is still 1. Okay? So, yeah, so I set them equal to each other. And what's a equal? 14. Subtract 3a from both sides, add 14 to both sides, and I get a is 14. Okay? So again, memorize. The two additional characteristics of a rectangle are the four right angles and diagonals are congruent. Oh, and let me say this before I forget. There is an online quiz that you need to take. It started this morning at 7 a.m. It'll end on Tuesday at 8 p.m. So you'll have 2 full school days and 3 weekend days to get it done. Okay, it's on Schoology. It says quadrilaterals or something on it. Okay, please make sure you take it. We still have a couple people that their grades suffered a little bit last term because they didn't ever take those quizzes. Okay. All right. I just want to say that before I forget. Okay, then let's prove that, use a coordinate proof to prove that this is a rectangle. okay? We're going to be doing this like for a week. So if you learn kind of the general flow of it, it's going to serve you well. The first thing, remember that a rectangle is a parallelogram that has, and then there's characteristics about a rectangle. So the first thing you have to do always for all these shapes is prove first that it's a parallelogram. Okay, remember opposite sides are congruent, opposite sides are parallel, diagonals bisect each other. You have to prove first that this shape is a parallelogram. Then we can prove it's a rectangle. Okay, so if I want to prove first that it's a parallelogram, for me slope is easier. Does anybody have an objection? Yeah. So I'm going to prove that the slope of AB and CD is the same, and the slope of AD and BC is the same. So, and remember, I'm doing this to prove that this shape is a parallelogram, because that's what I have to do first. Then I can prove it's a rectangle. But first I have to prove it's a parallelogram. So I'm going to find the slope of AB and DC. Then I'm going to find the slope of AD and BC. Okay. Obviously you can count. I'm going to calculate them. Well, actually, can you calculate them? Just because there's a couple people who are still having trouble with that. So can you calculate their slopes? This is a 3, 3. This is 0, 6. This is -1, -1. And this is -4, 2. Okay. So take a second and calculate their slopes. It's good practice. Okay, so ordinarily, I always pick right angles. Like I always, do you know why? Yeah, because I already proved the slope. Good, nobody's gotten that quick up today. Right, I've already proved that I've got these slopes. So to make right angles, what do I have to have? Perpendicular lines, which are opposite reciprocal slopes. So now I've already calculated those. I could just say they're opposite reciprocals. So when I get to choose, I always choose right angles just because it's easier. But they told us we have to use diagonals or congruent. So what do I have to use to prove diagonals are congruent? Distance formula, right? I'm going to find the lengths of BD and AC. All right, so do that. Oops. All right, so the symbol for rhombus is a rhombus. The characteristics are, first, it's a parallelogram. So all the characteristics of a parallelogram apply. And it has 4 congruent sides, diagonals are perpendicular, and diagonals bisect opposite angles. So it's all the stuff about a parallelogram plus all 4 sides are congruent. The diagonals make right angles, and they also bisect the opposite angles. So this diagonal bisects that angle, and this diagonal bisects those two. Make sense? So those are the, again, memorize. You got to know these. Okay? So those are the 3 characteristics of a rhombus. All right, so is there a way we can solve for A? Anybody have an idea how we could find what A equals? I'm sorry? Why? Oh, yeah, we're having a little trouble with the vocabulary. She said we can set this equal to 90 because why? What are these called? These diagonals are perpendicular, which makes right angles. So you're right. Okay, so I said 6a plus 18 equals 90 because in a rhombus, they're all right angles. Okay, so 6a is 72 and a is 12. Okay, how about solving for x? What do we know about those sides? They're equal. All the sides of a rhombus are equal. So wouldn't it have mattered where I wrote that? They're all equal. So I set 9x minus 11 equal to 4x minus 7. Let's see, subtract the 4x, add the 11, and I get 5x equals 4. Divide both sides by 5, and I get x is equal to 4/5. Okay? Why does it keep just... Okay, and squares are, if rectangles and rhombuses got married and had a baby, they'd have a square. Because a square has all the characteristics of a rectangle and all the characteristics of a rhombus, plus all the characteristics of a parallelogram. It's grandpa, right? So when you're proving a square, you have to prove one thing is true about rectangles, one thing's true about rhombuses, and then say it's a square. Therefore, it's a square. If it's true, if it has a characteristic of a rectangle and the characteristic of a rhombus, then it's a square. All right?